Hey everyone, what's up? In this tutorial, we're going to create the see-through anime eyebrow effect. It's pretty straightforward to make, but just a heads up, this method currently only works in EEVEE. So what we are going to do in this video, we'll start by setting up the necessary render and material settings, then prepare the temporary workspace. From there, we'll dive into the shader nodes and a quick compositor setup. Lastly, we'll look at some common issues you might run into and how to fix them. Yep, that's it. Let's go. First, make sure you're using the EEVEE render engine. Then go to the view layer properties. We're going to add an extra render pass from here. If we click this passes drop down, we can see variant of pass we can choose. In this case, we'll be using shader AOV. Right now, we don't have any shader AOV set up, so go ahead and click the plus button to add a new one. You can name it whatever you'd like, but for this tutorial, I'm going to name it ZTest Always. Now let's set up the materials. First, set which object will become see-through. In my case, it's the hair. Open up the material properties and scroll down and you will find the settings drop down. In the surface settings, enable any backface cooling options you need, and then change the render method to blended, as this is required for the see-through effect to work properly. Also, disable the transparent overlap. That's it for the hair material settings. Now let's set which object will be allowed to remain visible through it. For now, we'll make only the eyebrows visible through the hair. If you want to add more than one material, no worries, the setting is still the same. Now into the settings drop down. All settings is completely up to you except the render method. The render method is need to be deterred. Yep, that's it. Let's prepare the temporary compositor workspace. First, let's turn this into 3D viewport, then we use it to display the compositor result in real time by setting the viewport setting compositor to always. Then add some compositor in the compositor setting. You'll see some node, but we don't have to touch it right now. Next, add some outliner window so we can select some object. And lastly, add material setting window so we can work with the material setting effect. That's it, now we're ready for the next step. Alright, let's select the eyebrow material. Here we have the material output node. This node is responsible for displaying the eyebrows in the final rendered result. To be more specific, from this compositor render layer's image output. Now we have another renderer, an AOV Shader, named ZTest Always. Let's try plug it to where the image output connected. And now we have nothing to display. Well, that's because our ZTest Always is not using the same material output node as the final rendered result. Remember, our ZTest Always is an AOV shader, so we need to add the AOV output node. To add it, it's quite simple. Click this Add Output, then AOV Output. Perfect. Now the AOV output needs a name input to work. This name must match the one used in the AOV shader. In my case, it's ZTest Always. There you go. We see the eyebrow appear in black color. The color comes from this color input. As you can guess, now we can just plug the image texture color output into the AOV output color. And that's it for the main function. We're going to add another thing. But before that, I'd like to explain a bit about the value input here. We don't actually use it, but if you want to, it only works with the value output from the AOV shader, not the color output we added earlier. So this value is usually used for a complex mixing factor at the compositing node, mainly for masking. The result itself, it should be black and white color. Okay, the next thing I want to add is a visibility controller. So we can easily toggle whether the ZTest eyebrow is visible or not. To do that, we can easily use mix color node. Plug the image color output into the mix color slot B. From here, you can just use the factor to control between the slot A and B. To make it invisible, just change the slot A into 0 value and 0 alpha. Cool. One last thing I'd like to do is expose this factor value in the surface material menu, so it's easier to tweak and control. Right now we cannot see it because there is no input connected to the principal BSDF node. For this case, I usually just use a simple mix trick. Since this is a visibility function, it makes sense that we want the value to appear in the alpha section. Currently, I just have the image texture alpha output as the default, and this should not be modified. So what I wanna do is put the mix float node here, then have both image texture alpha output plugged into A and B mix float node. So in other words, the mix factor will always outputting the same value for principal BSDF node alpha. Now we have the factor value exposed in the material properties. Nice, we just need to add some value node, rename it into ztest always, then plug it into the mix color node and the mix float node. There you go, we have the ztest value exposed in the material properties. It will not affect the image texture alpha, it only affects the ztest mix color node, which is exactly what we want. Now let's frame this node and name it ztest always, just to organize it better. I forgot one more thing. If you want to control the alpha other than using the image texture alpha, you can add a matte multiply node after the mix float node. Then maybe add a value node and rename it to alpha, so that you can adjust it from the menu, which is useful for animation or other controls. You can also just use this multiplied value as a driver for additional nodes. In my case, I don't need it, so I'm just going to remove it. Okay, we're done with the shader material. Let's focus on the compositor. Now we just want to combine the Z as always with the image render result. To do that, we can just use mix color node, plug the image output into the slot A and the Z-test into the slot B. Now we can switch them from the factor value, right? It's 0 factor equals the default render result, which is the image, and 1 is the Z-test. So yeah, the next thing is we need to make that kind of mask for the factor. Luckily, we actually already have it. So we just need to deconstruct the Z-test image and use its alpha channel as the mask. We can just use separate color node to get it. Make sure the mode sets to RGB, then take the alpha and try plug it into the last dot just to preview it, making sure it behaves as it's supposed to. Yep, it is correct. Now let's plug it into the mix color factor and plug back the result into the final dot. That's it. If we test the alpha Z test, we can see it works properly as well. Now we can go back to layout tab, and if you want to view the result in real time, you have to change the viewport setting compositor to always. So there is some note about the effect you need to know. For example, I have more than one material for the effect, then one of your material have this kind of problem. No worries, the fix is quite simple, just enable the camera back face cooling. I usually just enable all of them though. Now let's say this back face camera cooling solution is not working. We need to check the mesh face orientation. We can enable it in the viewport overlay top right here, then see the problematic face. Let's isolate it real quick. Alright, after you're done, try selecting the face using box select like this. Then see the back part. It should be not selected. So what happened is your mesh face here is double side face. The front and the back part is have their own part. So let's delete this back part face. There you go. Now you should see the red color. And if you try selecting it, it should be selecting the front part as well. If the red part is somewhat in the wrong direction, select the face and press F3, then find normal flip function. Well, mine is already correct, so I'm going to flip it again, but not from shortcut, just to show you in case you cannot do the shortcut. Yep, that's it, it should be fixed. Now you can disable the viewport overlay face orientation again. Next is, let's say you've done animating and want to render it. Usually we render image by image, right? And if you see the result from the Blender, it looks normal. But if you save it with RGBA color, it will give you this. So the simple fix is just use the RGB color setup. I'm not entirely sure if there is another way to fix this, but it might be possible through the compositor node setup. But I haven't had a chance to experiment with it yet. So yeah, if you know other solution, feel free to share it in the comments below. That's all from me. Hope you'll learn something new. Thanks for watching and cheers!